And in the task sheet, we see that we have to do some visual inspection and then execute the following commands, tasks. Before we start doing things, we can really start just by looking at the data, and this will be already enough to uh, familiarize a bit with the types of variables that are there. All right, now we can start. Um, so this is the output window. So you just um, you can open Stata window and just file, open, and find this. It's not the previous file, I guess. No, because previous file we kind of took from the memory. Yeah, it was the system file. This one is like the one I sent you. But normally, if you click on this data file, it will open it. Yeah, so yes, maybe it will ask you first which program you want to open it with for the first time, but then it's normal. All right. If we look on the right, we'll see like it has 5 variables. In the bottom, we see it's 12,000 observations, quite a lot. And this is actually, this is the real data. So it's not some fake data for study purposes. That's the real data from the source, like from the type of data. It's called RLMS. So this is the data set, which is called Russian longitudinal multi-dimensional file, like, oh, sorry, survey, multi-purpose survey. So basically, it's the Russian representative survey, and it's a panel data. Panel data means that individuals are followed over time. So this is like we are dealing with the wave 25. Now there is also the wave 28 already available. So basically, the data is collected, has been collected for 20 something years. This is like wave 25. No, we can open only one data file in one window. However, we can have many data windows open. I'll show you the no, not this one. This one. Um, this is my screen. Yes. For example, I have, like I'm kind of bad at these things. So I have only 2 Stata windows open. So like Stata, I mean the Stata windows by these like black ones, so like um, the output windows. I have only 2 things. Sometimes I have even more. Um, all right, coming back. Panel data is a type of data when individuals, when we have variation not only between individuals but also within individuals over time. So like we basically find one person and go to this person 25 years in a row to see how he is doing. So like we see how changes, what changes happened in his life over 1 year. And this guy is kind of visited for 25 years, something like this. Okay, yes, our assignment number 3 will be instinct. You have to do like a very simple code and yeah, and write some comments about it. All right. So this data, Russian longitudinal multi-dimensional survey, um, is a very big data set. It's full of questions. So like there are thousands of questions. People are asked about the income, about the education, about the health, about the diet, for example. Yes, yes, it should be done in Stata because um, yeah, because honestly I can't read other files, other data processing software. I just know Stata and that's it. It doesn't really matter which version you have; they're all the same. So like you can import data. So like if you put like a file import, and then you can import this, for example, from Excel or other types of data. So this is what's the what the screenshot was. Yes, you're using the right. Yes, it's okay. It's okay that your data looks white. You see like these preferences. I have the classic theme. The standard now is this the white one. I just like I started working on Stata when it was like version like 7 or 8. That's why I just got used to this black one and yeah. No, I think normally the encoding is actually quite Stata is kind of liberal with it. Um, so I think there shouldn't be any problems with the with an encoding. Um, yeah. Normal Excel file can be easily exported to Stata, especially CSV. CSV is super simple now. All right, coming back to this data set. When we ask so many questions, no, Excel won't work. Like Excel will be like too long to check. Yeah, like the data code because you need to write the code and some comments to the code. That's why it's so easier to do with data. Um, by next, you mean it's assignment number 3. Yeah, like assignment number 3 is in data. The assignment you have now, assignment number 2. Of course, you can do it in Excel or whatever program you want. Yeah, only assignment 3 has to be. Coming back to the data. So when we ask so many questions, yeah, like thousands of questions, it's very hard to come up with like unique and explanatory names of variables. Yeah, sometimes it's easier just to say like it was question, for example here UH5, um, because there could be like many options, many types of questions when you ask the gender. Yeah, like it's respondent's gender. It could be the gender of your children, and they have many children. You have many questions about gender, and so on. So not to create confusion, you just say like, all right, I encode the numbers of questions, and then there is one document which is called survey manual, and there it's basically a big glossary of what these questions or what do these codes mean. And then they say like, all right, these codes mean code means that you are doing this is the question that and that. So for example, what was your breakfast today? Like this will be some question. Here we know that UH5, the question coded UH5 was respondent's gender. All right, that's good. We didn't take all of the variables because there are thousands of them. We just want to focus on these 5, and that's what we'll study now today. That's kind of enough for our functionality. Right. Now let us observe the data. We open this data editor, and yeah, this is how the table looks like. Yeah, we see like five variables. The first thing we have to look at is some of them are black. The font is black. Sometimes it's blue. Yeah, why is it the case? Because blue things, like blue values, are labeled values. So you see, like, if you click on a particular cell, on the top here, you see the value of this cell. So for example, if it's silo, it's equal to 4. If it's поселок типа, yeah, it's a 3. Kind of factor. I guess so. Yeah. Those are factor variables. Yes. So how do you think? Why do we keep it? Or let's look at gender. Gender is, let's start with gender. It's simpler. Like we have 1 and 2. Why is it easier to put numbers for gender instead of text? Because we could also, for example, we can create variables with text, yeah, like, and those are marked red. They are string variables, and string variables are shown in the table as red ones. So the blue ones are still numerical. However, we see this is the gender. How do you think? Why does it make sense? Why does it make sense to write gender as a number and not as a text field? For easier coding, yes, and also yes, exactly. It takes so much space, so much less space. Yes. So like this, if there like state that doesn't write the first 0, it's just it's 0.6 something. Exactly. It takes so much less space, and it's also like easier to write, easier to kind of analyze. It's the same, I guess, but it's definitely easier to store. And then like Stata knows that this is 1 and 2. These are kind of indicator variables. And then it assigns label. It just says like all 1s are Morskoy, all 2s are Chensky. Binary variable. This is not the binary data, because binary, yeah, it's like when the values are 0 and 1. Here it's 1 and 2. However, now we will change this variable, change this gender variable to make it binary. To make it really binary. So like between 0, so it's either 0 or 1. So how can we do this? So we can basically think about this like as a computer. So gender, like in Russia, yeah, like in Russia we have 2 genders allowed here. So the official statistics allows only for 2 genders in Russia, male or female. And then if it's like only 2 options, you can define a gender through kind of the opposite. Yeah, so for example, you can say like, if you can define gender with a yes or no question. Yeah. For example, if you ask somebody what color is his shirt, yes or no is not kind of a appropriate question. Not really. Stata doesn't have like any special type for binaries. It just treats them as normal numeric things. But of course, binary variables are already by construction, yeah, like more suitable for computing. Because you remember from this mathematical logic, yeah, like 1 is yes, 0 is no. And this is like very easy to include in some equations, very easy to use in the regressions and so on. So now we will create a dummy variable, and dummy is the same as binary variable, just in statistics. So to open this table, you just you can type in the output in the console, in the command window, you can just write edit and it will open you this table. Or alternatively, on the top, you see like here in the output, in the results, like these buttons of like edit or browse, they're the same. So you can just type edit and yes, exactly, exactly. State doesn't ignore zero if it's only a zero, because it's not a missing number, it's a zero. Honestly, actually, never noticed this, but it's a cool observation. Yeah, I'll tell my friends about it. Those friends who understand what theta is. So imaginary ones. All right. Yes, we could do this. We could just say like -1 to all values. Alternatively, what we'll do now, so basically coming back to binary things. Now it's a categorical variable. Yeah, so let me go back to the browser, sorry, to the output window. We can find some information about this codebook UH5. The codebook gives us some basically basic information about the variable. It tells us, all right, it's a numeric thing. This label thing means that the values, so like 1 and 2, are labeled according to this algorithm called UH5. It's the same name as the variable, however, it could be any algorithm we like. The range, it's either 1 or 2, only two unique variables. There are no missings here. So 0 missing, so we know gender for everybody. So, and this is what actually gender now, what do numbers mean? Now, at this stage, numeric categories assigned are 1 to males and 2 to females. So this is numerical data, but with these categories. Yeah, so like 2 doesn't mean that females are 2 times more something than males. No, it's just like it's like, think about this as a house number, like house number on the street. So like there is house number 1, house number 2, number 3, and so on. It doesn't mean that house number 3 is 3 times bigger than house number 1. No, it doesn't work. It's just a number so that we know which door to enter when we have to go there. And that's it. It doesn't give any characteristic of this building. So types of variables in status. Like we have two types, basically string as a text and numeric as the number. Here in this data set, all of them are numeric. All of them are numeric, but some of the numeric things, so like this one's blue, they have labels for these numeric things. So because we are interested what does 1 mean and what does 2 mean. Here we know 2 means females, 1 is male. Yes, this frequency, it shows us just how often we find observations with the UH5 equal to 1, 5,000, that much. We didn't write it, so it was written to us. So this was like already in the data. We just analyzed the data that we kind of found. So like, yeah, and then it's our kind of task to analyze it. And what can we do with this? I didn't do this. So I didn't do this. This was already given to us by the data. So it was in the data. I didn't create anything. And I just took it as it was. What to make the name? Yes, now we will do how to assign names and so on. yes, we can just like in the edit mode, we can just find the cell and change something manually, like in Excel, for example. Yeah, like in the edit mode. In the browse mode, you can't, but like edit mode is just the same thing where you can edit. So yes, in this type of data, we have only two genders. That's why we can define, for example, um, male as now for kind of to save space, male is already encoded with 1. So now let's say how to open the data set. So how to see the table. So table, we see tables if we just put here, you see like this data editor command, or we can just write in the command field edit. We hit enter and it appears. Yeah, like, and then let's see. Where is it? This one. All right. Yeah, some questions can be perfectly answered with yes or no. Because yes and no, yeah, it's super easy to encode. It's 0 and 1. And here, gender, we can answer, basically, we can determine gender of a person with a yes or no question. Because we can ask the person, are you a male? And if it's yes, all right, we understand it's a male. If it's no, in Russian official statistics, it automatically means that you are a female. Yeah, like because in the official statistics, we don't have more genders than 2. So like, and both are mutually exclusive. Yeah, so you can be only male or only female, not both at the same time. So, and that's why now, exactly, if we place 3 in the UH5, it will just have no label because state doesn't know what to do with this. But we'll come to this labels mean. Double is just some type of numeric. No, it's just some numeric thing. Like honestly, I don't know because yeah, they're all double. It's just some like how many numbers are there? I think it's something like this, or maybe that there are no negative values. So it doesn't really matter. What it matters is that it's numeric, and this is what we kind of already know. So this is the number, not a text. All right. Now, so let's converge this UH5 thing into a male dummy. Dummy variable, you remember, it's the name the same as the binary variable. So like 0 or 1 is the only options. So now we transform um, I think so, yes. So like actually like those numbers, like for example, this weight is also like it's a float, but yeah. I honestly don't never thought about these like types of numeric things. It's there, and we kind of so it doesn't matter for us. Yeah, like we can calculate both of them. Right. Now, let's say we rename the variable called UH5, and we make it be called name. Oh, sorry, male. Yeah, we just changed the name. We have transformed it from categorical variable. So categorically is like it assigns different types of different kind of bunches of characteristics to a particular observation. So it says like if it's 1, it's male, if it's 2, it's female, but we want to make it binary. So, and then we say like, all right, it's 1 if it's male, and it's 0 if it's female. That's why we say like replace male equal to 0 if And then we say like in which cases we want to make this replacement, because for those who have this value of equal to 1, it's already fine. We don't want to do anything with it. Like, all right, male equal to 0 if in all cases where male, and if we write condition, this is kind of this logical operator, we put 2 times equal. Yeah, not 1, but just 2. I don't know why. Just somehow easier for Stata to understand it. You hit enter, and you see like 5,407 real changes made. Oh, sorry. I made a mistake. I do it back. Male equals 1. So like this command is just kind of, those two you can ignore them because I assigned the wrong gender the value of 0. Yeah, because in reality it has to be, I'll put the break, yeah, like the comment, this was wrong. Now I can just, I know I have to replace male equal to 0 for everybody who is not a male. And this is like, they are female and they are coded with a 2 in our data set. Why do you use edit? So this edit is to open the browser where you can edit. So like this edit is just another way to call the table, so like the visual representation of it. thing. So like if no real change is made, it means that like nothing was changed. So like either condition was not specified or condition was kind of specifying the replacement, like the same as the replacement. So for example, if we write male equal to 0, if male equal to 0, we have no real changes made. Here we need to basically say like, all right, we need to assign value of 0 in the variable male to all people who are not males. Those people are females, so they are encoded with the 2, and that's what we do. Exactly. If you write the code book now, you will see that, oh, sorry, code book male, because we don't have UH5 anymore. Code male. See, like we have 2 things. So if you wrote 2 of these things, yeah, like 2 of these lines, it's good that it didn't work. Like it was wrong. Yeah. So like now you have to do this. Replace male equal to 0 if male, for every case male is equal to 2. And so like the first equation sign is like deterministic. You tell Stata what to do. And the second thing is that like every time, like for example, male is equal to 2. All right. And now you see, if we go, for example, now I can write edit. Edit is only to call the window of the output, sorry, not the output window, the editor, the table. I have to see the table. So I put it there, and it opens this thing. All right, and now we see that Stata kind of labels no, there is no revert command, unfortunately. No. Basically, if you do something wrong, you have to open the file again. But that's another advantage of Stata, that you can see on the left all the commands you've made. So you can just open the file again and click on the same things over and over until you reach the point where you made a mistake. All right, now we know that 0 assigned to females. Oh, yeah, because it's the male dummy. Dummy, once again, it's the binary variable. If we go here on the right to the value label window and put 3 dots, you will see that it's the value labels manager. Yeah. So basically, it has algorithms how to which labels to assign to different values of this variable, of variables in general. So basically, we know here that it assigns the label мужской if the variable is equal to 1. And it assigns the label женский if the thing is equal to 2. Here we know there are no 2's anymore. We by hand remove them. So that's why we can create a new label, and we can call it whatever we want. So we can call it male label. It doesn't have to be male. It can be like whatever label. I don't know. Whatever you like. Unicorn. This little window we opened, you see like here on the in the value label there is like these 3 buttons. We open it and it opens us, so like we click here and it opens this value label manager, and here we create our own new label. Like, all right, for all observations where where variable is equal to 0, we want to write it as a female. And for all observations where variable is equal to 1, we write male. Okay, we save it. And you see nothing happened with the male variable. Why was it the case? Because we have to assign this labeling algorithm to the variable. It still operates under UH5. Under UH5, which wants to label 2's as females, but there are no 2's anymore in the data. So that's why we select the male, open the drop down menu, and select the algorithm that we want to apply. So like, all right, we want to apply this algorithm. You see, like there are other labeling algorithms which we could use also, but we know that this one was made particularly for this variable. Yeah, so this is like, yes, in the properties, like here on the right hand side of this variables manager, in the properties you have this value label, and then you basically open the list, choose the one you want male label, and you see everything looks fine now. So where 0's were, we have female. When it's male, it's equal to 1. Of course, this is a very simple dummy variable. It's like 0 and 1. Here probably we don't need labels much, because we know it's equal to male, and then normally we know that, like, typically, very often in mathematics, in mathematical logic, 1 is yes, 0 is no. Like in this kind of computing, like there is signal or there is no signal. Like here we have we answer the question, are you a male? And the person says yes, then it's equal to 1. If the person says no, it's equal to 0, and we know that being not male in our sample is the same as being a female. So we kind of define one through the opposite of the others. We renamed it just because it was easier for me to operate with male than with UH5, which was initially for gender. And why is it called male now? Because it's characteristic of of being a male. Yeah, so for example, for those who are males, it's one, it's yes, and for females, it's no. That's why it's zero. We could do the same for females, for example, yeah, and then we would typically code females with one, so it's a female dominant, not a male one, and zero for those who are not females, and zero then it means males. So could you show how you edit these values? So like the values, once again, so so here in this property, do you see my whole screen? It seems like maybe not the whole screen you see. All right, now then you see like there are three buttons here, three dots on this button. And this opens the value label manager. And here you just create the new label, and then you tell how to call it, which values you want to label, and so on, and how you want to label them. And then you select the variable and assign label and algorithm. All right. Now you see like all these things were actually also duplicated with the code. All right. Yeah, I just didn't edit. We could actually erase it. Yeah, like, or we could use it. I just couldn't edit the old one because yeah, we could also edit the old one. It was the same. I just created a new one. I just don't have a Russian keyboard. That's why it was easier for me. Um, Easier for me just to create a new one. Yes, so we can either create, like, change these labels through menus, or we can just write the code. So here we select, all right, I want to do something with labels. What do I want to do? I want to define it. I call it mail label, and then I describe how this labeling mechanism works. This is one thing, one operation. And then you select, I want to label values of the variable male with this algorithm male label. If you want to clear the command window, to make a clear window, you can just hit enter until it becomes like empty. The output window, sorry, the output window. If you want to delete commands here on the left, you can just select them and also delete, and then it will become empty. All right. Now going back to our types of variables. Now we are ready to create the first task in the task sheet. We can create a dummy variable for those who live in a rural household. So we have this variable called status. I don't know why it's called status. It's kind of not very intuitive name. We can just see what does this variable include. We know it's type of residence. Yeah, we know from the label it's type of residence. We say code book status. So status is the name of the variable. Right. And that's what we see about this variable. We see again it's numeric. It's labeled according to the labeling algorithm status, the same as the name of the variable. So people who created this algorithm were not very they didn't want to make confusion, so they created labeling algorithms with the same names as the variable names. However, it could be different also. All right. Range. range of these. Oh, sorry. All right. Range between 1 and 4. 4 unique variables. Oh, sorry, 4 unique values. So like 1, 2, 3, and 4. Yes, exactly. 4 possible options. Again, no missings, so 0 missings. And this is how this tabulation looks like. It says 4 unique values, and each one has its own particular label. So if this variable is equal to 1, we know it's Oblastnoid center. Yeah, because imagine the data file where every type of residence is written with a text. If they really write Oblastnoid center, every time it's Oblastnoid center. It's a lot of space. Yeah, like every Cyrillic letter is like, I don't know how many numbers, 20 numbers. Instead, we just say like run, we write 1, and it's like every time you see this 1, you should just, like data knows already that it marks it with the words Oblastnoid center. However, the data file, you see, like it's super small. It's like less than megabyte. Yeah, like it's half a megabyte, even less. It's tiny. If it would be like text fields, it would be much larger. No. So like Stata doesn't always number options from 1. It was basically done by people who created this data. They said like, all right, we have 4 types of residents. Let's just number them one by one. And they said like, all right, 1 will be Oblastnoid center, 2 will be Gorod, 3 will be Поселок городского типа, and so on. So yeah, I don't know what's the difference between Gorod and Oblastnoid center. Maybe one is smaller, another one is bigger. It's not what we kind of are interested in. Because these variables are called categorical variables. Yeah, so once again, it doesn't show any kind of interpretation of the number 2, 3, and 4. It's just like said like, all right, it's the residence of type 4. It doesn't mean that Silo is 4 times something bigger or smaller than поселок городского типа. No, it's something different. What does frequency mean? Frequency means how often, how frequent we find this, for example, value in the data. And it says like for 5,100 observations, the variable status is equal to 1. Many cities in the district. So yeah, this is what this frequency means. Yes, we can import data. We can import from CSV file and we can export to CSV file. So here, the missing, it means that we have 0 missings out of 12,554 observations. Like, this is what basically it tells us. This comma is to separate thousands. Yeah, like it's not the decimal, it's 1,000 separate. Yeah, like in Russian, we have the opposite here. Like so, we have like dot to separate thousands and the comma to separate decimals. Here it's the opposite. All right. Yeah. Speaking about this division, so we know that one person can be attributed to one category, and that's it. So, like, if what the difference is there, we don't know, but they were attributed to these kind of types of residence. No, normally we don't do anything with missings. Sometimes we can drop these observations, not to have like them in the data so that the data can become shorter. But normally Stata doesn't take them into account if it calculates something. So it's kind of convenient because sometimes, for example, you can have a missing in one in one variable, but not in another one. So like you can use it, this observation, and yeah, drop. You can just like write drop, and then you can, if you write the name of the variable, it will drop this variable, or you can write, for example, drop if, and then it will tell us that it will drop observations if some condition is, for example, status equal to 2. So it will drop all observations where the variable status is equal to 2. So it's like people living in borders. Right, coming back to our rural dummy. We have to imagine we want to separate people living in rural areas. Yeah, so for example, we could say like, right, drop if male equal to missing. So if we have no information about gender, we want to drop this because it doesn't give us any information. We hit enter, and here it doesn't delete anything because we know gender for everybody. That's why it doesn't do anything. When value is missing, it equals to a dot. So this is like the only way to make a missing value in Stata. So this is how it understands that it's a missing. Right. Now the task is to create a rural dummy. Yeah, rural dummy means that we want to separate people living in, let's say, rural areas are only silo. Yeah, like we can do it whatever way we want. We say like, all right, people live in a silo. This is rural residents, and the rest are living in these urban areas. Um, so uh, exactly. So we basically will assign 1 to everybody who lives in rural areas, and rural areas is silo, and 0 to everybody who doesn't live in silo. And if people don't live in silo, we know that they live in one of these 3 types of residence. No, we'll get actually one new variable, because if we do this rural dummy, yeah, like for us it becomes no difference if person lives in Oblastное center or in город. Yeah, like it's the same, because what's kind of common in these 2 types of residence? Both of them are not silo. Both of them are not rural, and differences between them we kind of ignore. We're not interested in it now. So we can just create a new variable. So we write generate or gen. We write this command. We say how the variable will be called. It will be called rural. Yeah, we can come up with any name we want. This is just the name. And then we say equal to, and then if we open the brackets and write in it a condition, So status equal to 4. Remember, status is our name of the variable. So this variable status. So again, condition, like when we write conditions, we have two equation marks. Basically tells us yes. If we want to create it categorical for every new option, yes, then we'll have like 4 dummy variables. Exactly. Here we want to oppose, basically, to separate villages, so like silo, to all other types of residents. However, we could do this for every type of residence. So for example, we say like, all right, поселок городского типа is somehow special type of residence compared to these two and compared to silo. Then we would have like a special dummy for поселок городского типа separately. So here, yes, gen is generate. And so like we generate rural equal to, and if we write this condition in the brackets, it basically tells data, so rural is equal to 1 every time when this condition is fulfilled. So every time status is equal to 4, this value of rural is equal to 1. And every time it's not fulfilled, so every time status is not equal to 4, it equals 0. So we hit enter, and it created something. Yeah, we can tabulate it. Yeah, we can tab this row, and tab command or tabulate is basically repeating the last part of the code book, like this tabulation. So we hit enter, and then we see what happened to our what kind of was generated. I think, wait, honestly, like, I'll just drop the variable to check if it should be written without gaps. No, actually, it's fine with the gaps. Like you see, nothing changed. Yes, we will have a new column. We'll have a new column if we go to the data editor again. Which we see that now we have a new column, new variable called rural. And we see like it's 0 for regions which are not equal to silo, and it's equal to 1 if it is silo. So here it's 1, here it's 0 again. Can we rename it with label? We can actually, yes, exactly. It's true and false. Yes or no. It's easier to say yes or no. Yeah, like in this binary thing. What the last column in this? All right. I'll come to this now. All right. All right. Going back to our this thing, the output, the tab command. So frequencies, as you remember, how often we see this value in our data sample. So like 9,000. This percent shows what share of our data set has rural equal to 0. And so like 73% have it equal to 0. And 26% have it equal to 1. The cumulative actually, I think it shows us cumulative distribution or cumulative probability of this variable. So like here we have only 2 categories. It's not very easy to explain. So I'll go back to this tab status, and here we have 4 categories. So basically it shows us cumulative probability. So like cumulative is like, yeah, like when you sum up probabilities. So here we see like, all right. So for example, if we take a random person from our sample, it's random, yeah, like, you know, like we close our eyes and put the hand in the bag and pick up a random person. So there is 60%, sorry, there are 40% that this random person lives in Oblastnoy Center. There are 26% that this person will be living in Gorod. And this cumulative probability that cumulative thing means that with a 66% probability, he lives either in the Oblastnoy Center or in Gorod. So like this is kind of sums up like 40, 26, and then it comes this cumulative. So like we can say like with a 66% probability, a random person from our sample lives in one of these two areas. And like if you add the third one, we see like we can say that there is 73% probability that this person lives not in a city. Oh, sorry, not in Silo. Here, because like cumulative thing, yeah, like tells us that like with a probability of 100%, this person lives in one of the four. Yeah, so like in 100%, we're 100% sure that the person lives either in Oblastnoy Center, Город, поселок городского типа, or Silo. So all of them. Yes. And you see, like this cumulative probability tells us that 73% of our data sample live not in Silo. And this is exactly what we see here in the rural dummy. Yeah, I will send you like after the next class, you will get the whole code I'm using today. You'll get it, yeah. All right. This is the rural dummy. So now we see that like, for example, 26% of our sample live in rural areas. All right. This can be roughly thought of as the urbanization rate in Russia. Yeah, like because it's a national representative, so everything that happens in the data set is actually can be translated to the whole Russian population. So 26% of Russian population, 26 of them live in the rural areas, so in Silo. All right. Um, so now what's next? So age. Now we have to inspect the age and do something about the outliers. All right. We go back to, we start with the age. First of all, like you see, like it's called UH. As I told you, there could be many variables in the initial big data set with age, so it has this like UH thing. I will just rename it for convenience. Yeah, just not to write this underbar every time. I just like I rename this and it will be just called age. It's easier for me to write every time age instead of U underbar age. You could have kept it. All right. Now, if we want to find something about the variable, codebook is one thing. Another option is to use sum, because yeah, like you see, like from the label, it's number of full years the person has lived. All right, it's very self-explanatory. Like person is equal to, sorry, this is a continuous variable. It's not categorical. Yeah, like if age is equal to like 20, it means you lived 20 years. If you compare age, it's super easy, yeah, because it's not category already. you know that like person aged 60 is older than a person aged 20 also. Yeah? So like this is continuous, very easy to interpret, very well. However, now let's see how it's distributed. So if you want to find some commands, you can write help and then the name of the command. It will give you some more information. So help. So for example, now we'll use sum command and it tells you like, all right, here's two options. Actually, summarize command. Summarize, and we can shorten it with the sum. All right, we write sum age, and it gives us very simple. It's called summary statistics. Yeah, like very basic, very kind of simple and understandable. What is, if you look at these statistics, what is confusing here? What is weird? What is strange? I can tell you it's somehow like, yes. Minimum is actually fine. Minimum is fine because there are people aged 0. They are just babies. Yeah, we have babies in the country. They have 0 full years. They haven't lived any full year. They could be like 3 months. Yeah. Yes, exactly. But like the mean and the minimum, yes, standard deviation. This is standard deviation. So like this is standard deviation. The mean is super weird, and the maximum are weird. So this is somehow strange. If we look at it, now maximum is not the sum of all items. No, it's really the maximum value, maximum kind of unique value. So to find out what it is, we can just tell Stata to list us. So no, mean is the average. That's like it's average of all values. Yeah, let's see what happens here. Oh no, before, just write. All right, so there's a hypothesis that it could be not counted in years in some other units. So I can say some age and write the option detail. So like comma starts the options, and then here we write detail and gives a bit more advanced things. We also see the like mean, standard deviation, but it also gives us the distribution. So like the lowest percentile, the upper percentiles, and so on. No, we didn't do anything. We just created a simple average. We told state actually to do this. And we see like that most of the time, the values are kind of normal. Yeah, like 98 is kind of rare, but it happens. We've seen this on the TV. Yeah, like this is too large. Yeah, maybe there is a mistake. Why not? Here we can actually list and stated to list as all observations. Let's say have like this ID variable is just the identifier of the observation. Yeah, so like we will want to see which identification it has to be in, and age. Yeah. So we want to find it. We actually want to find it and look at this weird number, what it is. So we say like we want to list this household ID and age, and if we just type it like this, starts listing all of the data. It's like all 12,000 observations will be listed here. It's too long. We can just break because we don't want to see all of them. We want data only to point us at those observations where age is bigger than, let's say, 200, because we already know that people don't live 200 years. What's wrong about these numbers? How do they look like? When they hit enter, it tells us that it's only one observation. We know, so like this first number, it's the line number in the browser, like in the data browser or editor. So it tells us it's line number 11921, and it's, see, like instead of age, it has this затрудняюсь ответить. It's not stated telling us. We could say like, all right, we could say also like more than 100. Yeah, like we could have like more than 100, and we still see it's only one observation. All right, it's observation in line number 11921. Data didn't even go crazy. No, it just told us that like this is something wrong there. Not wrong. It's like that's what you are looking for. So like, all right, we are looking for an observation with age bigger than 100. Yes, and basically, if we go there to the editor and look for this observation in line 11,000, oh sorry, yes, 11,921, we see that this is actually, yes, this is actually the labeled text. Oh, sorry, the labeled value. You remember in the beginning I told you that blue font is for numeric variables with labels. Very nice results to see there. Yeah, we took, like, now we told Stata to tell us in which cells we have values which we believe not plausible. And I said like, all right, age bigger than 100 is something weird. And Stata told us it's only one cell which satisfies the condition, this one. And in this cell we see like age is equal to 9, so basically 10 million. And now I'll show you what we can do this. We can drop it. We can if you have this encoding, you can tell Stata again to list age if age is bigger than, say, like 100, and it will give you the line number. Yeah, then you'll have to find it at some point. No, this label was actually in the data. So this was in the data. Stata didn't generate it. So it was generated by people who created this data, and it was on purpose, because if we put some kind of normal value here, we would say, all right, this is an age. So for example, 0 is not the proper thing to do, because no, 0 is, it can happen, because yeah, like babies can be 0 years old. Yeah, like when they're born, they're like 3 months, so there are no 0 full years. Yeah, so like why was it this way? Because Stata doesn't allow for text and numbers to be in one variable. So if Stata sees that like one value is text, is a string thing, all variable becomes a text variable, a string variable. So that's why Stata doesn't doesn't allow to combine text and numbers. So here, the people who were creating this data, they said like, all right, we just put the technical code instead of the text. So this 9997, the fractional values could be, for example, here, yeah, like in weights. For full years, we're just like not interested in this full year. We're not interested in the how many months they are. We know they are babies, and this is kind of enough. Like kind of attributes them to this category of babies and so on. We can change the data type. Yes, we can change it from string to numeric sometimes, but it only is possible if we have like no text left anymore. And here we can make this, for example, variable text one, but then we won't be able to analyze it. We can calculate mean of a text field. Yeah, like so like this is a technical code so that every time we, for example, open the data, we find, oh, this is a weird observation. Like, all right, this is a weird observation. We find the label, and so we find it, and we know what it was. Why is it? And this way, because the person couldn't answer. Why didn't they drop it? Because sometimes maybe this person answered all other questions, and it was interesting, this observation. Another thing is that, for example, this guy couldn't answer. All right, this is information by itself. So we know that, for example, in Russia, in this national representative sample, somebody will be refusing to reply to this question. All right, that's another thing. Maybe we want to analyze who this person was who didn't want to tell us his age. We know it's a male from Oblastnoye Center. All right, that's already some information. That's kind of interesting. That's why they didn't drop it to let us decide. Here, of course, we won't analyze why was he refusing to answer. Exactly. So we will replace it with a dot. So we will say like replace age equal to dot. This is a missing variable. This is a technical thing for state already. So all variables that are marked with a dot, they are missing. Because we cannot say it's equal to 0. Because most likely this person was not aged 0. It wasn't a baby. It was just some weird, most likely middle-aged guy who said like, ah, yeah, no, I won't tell you my age because I'm paranoid. All right. We replace age, but not for all of them, because this will replace age for all observations. No, we say like only in one case, if age is, we could say like either equal to 999 and this technical code. I don't remember this technical code, yeah, but I know that like we have no variables with age, sorry, no observations with age above 100. Yeah, so like we just say if age is bigger than 100, it's a missing data. We hit enter, and Stata tells us that it made one change, and one observation is now missing. All right, that's it. No, there won't be error now, and because Stata knows that it's missing, it just doesn't include it. Yes, exactly. So this is exactly what we want to do now. So sum age, and now we see that we could replace age in the cell by hand. We could just like open this data editor, find the cell and do it by hand. Yeah, this is also possible. Here it's just, like not to find this cell, I just say like, I remember like this is a very implausible option. So I say like, if age is bigger than 100, it's a miss. Yes, exactly. Then, yeah, what if there were like 20 guys like this and then we have to find them and yeah. Here it's kind of much simpler. Yeah, we put a dot. I think if we delete it, it's the same. But yeah, if we put a dot, that's understandable. All right. And told us, all right, made one real change, one is missing, and now we see that like to calculate the mean, it uses not the whole sample, but one observation less. Yeah, like so, this is number of observations for which we have data in column. Oh, sorry, in for variable age, and this is how many observations we have in general in this data set. Right, then we see now that we have like an average person aged 41 in the data set, maximum is 98. This is kind of rare, but this happens, all right? And the minimum is 0. Those are kind of babies. Babies have no full age and no full years. That's fine. Now, the last thing I will tell you is this variable called post-stratification weight of each individual. It's needed here to make real inferences about the whole Russian population. So basically, the idea of this sample, of this data, is that you survey only 12,000 people, and it's enough to say any claims about the whole Russian population. However, for the whole Russian population, we have to survey all ages, yeah, because these people aged 98, they are also part of Russian population. However, if you look at the number of people aged 98, yeah, like in the whole Russian population, maybe there are only like 10 people like this for the whole country. Yeah, and if you randomly pick up 12,000 people, there will be no person aged 12,000, aged 98. This is super rare. We cannot ignore it, but at the same time, this guy is actually pulling the mean upwards because he's kind of, we say in this case, he's overrepresented. Overrepresented means that like we have more people aged 98 in the sample than we have in general population. Yeah, like relatively. Here, this guy is like one person out of 12,000, while in reality, we have I don't know 3 people aged 98 out of 140 million. And that's why, if we go back to the browser, to the table, we see that these weights they are normalized already. Yeah, we're finishing now. They are normalized around 1, and some people are they represent more people, and some people represent less people. So, for example, look at these person age 95. His weight is way below 1 because he represents a very tiny share of population. There are very few people like this. We cannot ignore them, but we also have to kind of, their weight is lower than the weight of, for example, people aged 19. These people have to be these people are underrepresented because in reality we have a lot of people. Yes, we can sort. We can also sort the command. So like we just say like sort and sort and tell which variable we want to sort it accordingly. So like here we could say like sort, I don't know, age, and it would sort by age. These weights are calculated not automatically, they're calculated by people who created the data, who collected it, and then they have their own algorithms how to calculate these weights. This is the kind of what most times statisticians work with, like calculating these weights. So if we want to find the real mean age in Russia, we have to use this AW, this is analytical weight, in the square brackets, AW, with this weight, we say like it has to be weighted according to this variable, and then hit enter, and we see that now mean is a bit lower. Of course, because like this guy age 98, like it's super rare. We have to kind of importance of this information kind of slightly less than importance of person aged say like 19, because we have many people aged 19 and very few aged 98. How to sort in reverse order? Honestly, I don't know. There are commands, but like they are not the most intuitive commands of data. How to sort in reverse order? Um, yes, this is one of the drawbacks. So the easiest thing would be like really to create the kind of the inverse of the variable, so like one or like zero minus the variable, and sort it then according to this variable. Yeah, but you can Google it. Like there are suggestions how to use. Like no, you don't have to know how to calculate weights. It's just the idea behind weights is that actually, if um, you want to make real inferences about the whole national population, you have to use weights. However, normally nobody does it. Unfortunately, like in real like work, people often ignore weights because they say like, yeah, we have some difference between 41 and 38, but in reality, like nobody cares that much, and it's like, all right, not to get um, to this weights business, we just ignore them because also to calculate weights, there is a methodology, and sometimes people kind of argue about it, if it's wrong or not. So like, what do you mean by separate? So like the graphs, yes, we can do. For example, we can use a histogram age, and this is the histogram. Yeah, like it shows us distribution um, yeah, of these ages in our sample. If you want to um, have like this filtering thing, you can see just on the top that like you just filter by expression, and then you can say like, for example, age bigger than 50. You apply filter, and you see only those people who are older than 50, even though the rest is still there, still in the data. We just don't see them, but they are there. They are not dropped. All right. All right, that's it. That's all I wanted to tell you. Sorry for being late. So next time we'll go on with the same kind of task sheet with the same data. No, we'll have assignment 3 after next class or even later. So like, and so next week is actually free from assignments. That's the idea. And yeah, so you can look at the data file at the task sheet. So maybe you can already have ideas how to solve other questions. Now you're kind of quite capable about it. And then yeah, we'll discuss it next time. All right. See you next week. So the grades for assignment 1 will be, I think, I hope tomorrow. Tomorrow, Monday, so like somewhere soon.